Today we'll do another example of a special series called the telescoping series. Let's do the prototypical example of a telescoping series. Suppose you have the sum n equals 1 to infinity 1 over n times n plus 1. Well, the clue here is if you have something that has two factors here, you can go back to your rules of integration and use partial fraction decomposition. And break this up into two. The idea of telescoping is, suppose you have two terms here. If you can write this in a form where you're subtracting things over and over again, and let me redo the notation, instead of a1 and a2, if we have ai minus ai plus 1, where the next term is always smaller, then we can do a telescoping series. So sometimes you might just see two things being subtracted together, but that's not always the case. One thing you can recognize is if we have two factors, we can decompose into something like this by partial fraction decomposition. So let's do that. We have 1 over n times n plus 1. We can write that as a over n plus b over n plus 1. Well, what's the common denominator? Common denominator is n times n plus 1. The left-hand term already has n times n plus 1 on the denominator, so we don't have to multiply by anything. A has an n in the denominator but does not have an n plus 1, so we multiply the numerator by n plus 1. Right? What's happening behind the scenes is we are canceling the n, and we still have to multiply that across. And similarly, here the n plus 1 cancels, but we have to multiply the b across. So b times the b times n. Okay. And now we can solve for a and b. I like to just set some numbers in these cases, so we can set n equals -1 to get rid of this term, and we can set n equals 0 to get rid of this term. So when n is equal to -1, we have 1 is equal to 0 plus -b. That means b is equal to -1. On the other hand, if n is equal to 0, we have 1 is equal to 0 plus 1 is 1, and that term vanishes. So a is equal to 1, b is equal to -1. Putting everything together, we have 1 over n times n plus 1 is a, which is 1 over n, minus 1 over n plus 1. So together we have sum n equals 1, n equals 1 to infinity 1 over n times n plus 1. We can rewrite that as the sum n equals 1 to infinity. I like to put parentheses here just to make sure what we're talking about. 1 over n minus 1 over n plus 1. Now let's plug some points in. When n equals 1, our first term is 1 over 1, which is just 1, minus 1 over 1 plus 1, which is 2. Fair enough. Let's try another term. Next term is 2. 2 will have 1/2 minus 1 over 2 plus 1, which is 1/3. Let's do one more for safety's sake. N equals 3. We have 1/3 minus 1/4, and we continue forever. What do we notice? -1/2 and 1/2 cancels. -1/3 and 1/3 cancels. -1/4 will also cancel. And the numbers will grow smaller and smaller. And the only thing that will not cancel is the 1. So we can say, therefore, the series we can say the series converges to 1 by telescoping series, or since this is a telescoping series. Awesome.